In a village, if it rains on one day, the probability that it will rain on the next day is 0.8. If it does not rain on one day, the probability that it will rain on the next day is 0.6. A weather forecaster says there's a 70% chance that it will rain in the village on Monday. And we need to work out an estimate for the probability that it will rain in the village on Wednesday, showing all of our working. So I'm going to draw a little tree diagram to help us. So we're starting off at Monday, and this path is going to be the fact of it raining, and this is going to be the fact that it doesn't rain. And we're told there's a 70% chance that it will rain in the village on Monday. So as a decimal, that's going to be 0.7, which means there's going to be a 0.3% chance or 30% chance that it doesn't rain on Monday. Because the overall probability has to be 1, because it will either rain or not rain. Those are the only possibilities. So there's a 100% chance that it's going to rain or it's not going to rain. So 0.7 plus whatever the probability of not raining is has to equal 1. So we can work out that the probability of not raining is 0.3. Because now what I'm going to do is I'm going to write here a T for Tuesday. I'm going to let the tree branch off and see what happens. So focusing on this branch next, we're told if it rains on one day, the probability that it will rain on the next is 0.8. So it rained on Monday. On Tuesday, what's the probability that's going to rain? Well, that's 0.8. And again, using the fact that we know that the probabilities have to equal 1, the probability of it not raining is going to be 0.2. Now, focusing in on this path here, the difference we got is that on Monday, it didn't rain. And we're told in the question, if it does not rain on one day, the probability that it will rain on the next is 0.6. So now this path, the probability of it raining on Tuesday is going to be 0.6. And not raining, again, using the fact that they add up to 1, is going to be 0.4. Now we've almost made it to Wednesday, so that's our goal. We want to work out an estimate for the probability that it will rain in the village on Wednesday. So it rained on Tuesday. The probability for rain, again in the question, if it rains on one day, the probability that it will rain in the next is 0.8. And again, no rain, because it rained on the Tuesday here. The probability of no rain is going to be 0.2. It didn't rain on Tuesday. And we know if it doesn't rain on one day, the probability that it will rain in the next is 0.6. So on Wednesday, probability of 0.6. And then no rain, 0.4. And for this branch, we've got Wednesday here. So again, because it rained on Tuesday, probability that it will rain on Wednesday is 0.8. And no rain is 0.2. And lastly, this path here, it didn't rain on Tuesday, so the probability of it raining on Wednesday is 0.6. And the probability of no rain is 0.4. We're working out an estimate for the probability that it will rain on the village on Wednesday. So which path down the tree would satisfy that condition? Well, okay, so if it rains on Monday, and it rains on Tuesday, and it rains on Wednesday, that would satisfy the condition of it raining on Wednesday. And when we talk about probability, when we see the word and, what we're going to do is we're going to multiply. When we see the word or, we're going to add. So what we had is rain on Monday and rain on Tuesday and rain on Wednesday. So 0.7 multiplied by 0.8 multiplied by 0.8, giving a value of 0.448. Now we could also have it raining on Monday and it not raining on Tuesday, and then it raining on Wednesday. So 0.7 multiplied by 0.2 multiplied by 0.6, giving 0.084. So I'm going to look at the other path. Let's say that it didn't rain on Monday, and then it rained on Tuesday, and then it rained on Wednesday. That would satisfy the condition of it raining on Wednesday, and would give us 0.3 multiplied by 0.6 multiplied by 0.8, giving 0.144. And last but not least, we could say that it didn't rain on Monday, and it didn't rain on Tuesday either, and then it rained on Wednesday. So 0.3 multiplied by 0.4 multiplied by 0.6, giving 0.072. So now we've done all the paths we can go through the tree to meet the condition of it raining on Wednesday. So for it to rain on Wednesday, this could happen, or this could happen, or this could happen, or this could happen. I said or, so we're going to add together. So to get the probability that it will rain on Wednesday, we've got 0.448 plus 0.084 plus 0.144 plus 0.072, which equals 0.748 is the final probability. So we get 2 marks for the working we did down here. 1 mark for then adding them all together. And then the fourth and final mark if you get the correct probability of 0.748.